This video is lesson 2 of the Hands-on Equations learning system. And in this lesson, we're going to see how we can use our game pieces, the pawns, the number cubes, and the balance to help us solve written equations. At the top of the screen, you're going to see an equation, and this equation probably doesn't look like something that you're used to because this equation has mysterious values in it, x values in it. These x's actually have a fancy name. They're called variables. And a variable just means that its value can change from equation to equation. However, like I said in our previous video, within this equation, within this problem, x's value is the same. If its value is 3 over here, its value is 3 over here and 3 over here. But between equations, x's value can vary or change. Our job is to figure out what is the value of x in this particular equation. If we look at this equation, this means 2 of the x's plus 1 more x, all of those combined, so 2x's plus 1 more x, so that's 3x's altogether, has the same value as taking that same x and adding 8 to it. We can use our pieces to set this up. So over here, we want 2x's. I'm going to take 2x's and put them in the balance. Now I want 1 more x right here. So I'm going to put 1 more x up here. And on the right-hand side, I want 1x and the number 8. Okay, so now we have represented our written equation using our pieces. And now we're ready to use trial and error to try to solve. So just like you did in lesson 1, pick a number to start with. You can start with 1 and just test it. 1 plus 1 plus 1, that's 3. 1 plus 8 is 9. 3 does not equal to 9, so we do not have a value that works for x yet. And just continue working until you get to the solution. In this case, eventually you would get to 4. 4 plus 4 plus 4, that's 12. 4 plus 8, that is also 12. So you'd find out that x has a value of 4. You then would perform the check, just like you did in lesson 1, and you'd say, okay, 4 plus 4 plus 4, that's 12. 4 plus 8, that's also 12. 12 on the left, 12 on the right. I know that those are equal, so this is a true equation when x equals 4. Let's look at another example. This one says 3x's plus 1 has the same value as x plus 7. So when I take 3 of some mysterious number and I add 1 to that value, I get exactly the same as when I take that same mysterious number and I add 7 to its value. Let's now set this up. I want 3 of this mysterious number called x-min, and then I'm going to add 1 to it. That should have the exact same value as if I took just that mysterious number and add 7 to it. Now we're to the point where we're just going to do our trial and error. Start with, you just pick a starting point. I'm going to pick with 1. 1, 2, 3 plus 1 is 4. 1 plus 7 is 8. 4 does not equal 8. So my answer is definitely larger than 1. I'm going to skip a little bit ahead. Let's try 3. 3, 6, 9 plus 1 is 10. 3 plus 7 is 10. So I have solved. I think that x equals 3. And I say I think it's equal to 3 because I'm not sure until I check. When I do the check, I'm plugging in what I think x-min is equal to, and I'm now going to double check to make sure that I didn't make a mistake. So on the left-hand side, 3 plus 3 plus 3 is 9, plus 1 is 10. On the right-hand side, 3 plus 7 is 10. I have confirmed that the left-hand side, the right-hand side are balanced when x equals 3. Let's look at one more example, and if you want to try this on your own, this would be a good time to pause the video, work it out on your own, and then come back when you think you have the solution. This equation says 4 x-men have the same value as 3 x-men plus 5. So on the left-hand side, I'm going to put 4 x-men. Be careful, the most common mistake made here is putting the number 4 and then an x, because that's what it looks like up here. It looks like we have a 4 and then an x, but this means 4 of the x-men. If it meant the number 4 and then an x, we would see 4 plus x, and notice that there's not a plus sign right there. So on the right hand side we have 3x plus 5, which means we want 3 X-Men plus the number 5. Notice that there's a plus in between when we want to add a number cube. So now that we have our equation set up, we can use trial and error to solve. I'm going to start with 2 this time. Count by 2's. 2, 4, 6, 8. 2, 4, 6 plus 5 is 11. 8 does not equal 11. Because that was too small, I think my answer is going to be bigger, so I'm going to skip a little. Let's try 4. 4, 8, 12, 16. 4, 8, 12, 17. I'm getting really close. This side was 16, this is 17, so I'm still not quite there. Let's try 5. 5, 10, 15, 20. 5, 10, 15 plus 5 is 20. So I think that x equals 5. I'm going to confirm that by doing a check. And I kind of just did the check when I counted here, but we'll confirm it again. So on the left-hand side, I have 5 plus 5 plus 5 plus 5. That gives me 20. And on the right-hand side, I also have 4 5s, which is 20. My check confirms that my equation is balanced when x equals 5. So in this lesson, what your goal is to translate a written equation, for example, like this, into what it would look like on a pan balance using your game pieces. And then once you've translated that expression from numbers and letters into the game pieces, then you can go about using trial and error to solve for x.